right, guys, this is Miss Katz, and today I've got to find my microphone. That might help. This is Miss Katz, and today we are going to talk about how to use a proportion to solve percent problems. Well, not only proportion, but a lot of different methods to solve percent problems. So a percent means out of 100. Okay? Every percent is out of 100. It's if we took 100 as our base, how much of that 100 are we talking about using? Okay? When you get a percentage on a test, your top score would be what? 100. And as we remove things, it's a portion of that 100 that we take away. That's where those percentages come from. Percentages represent a part out of 100. Okay? In math, can somebody tell me what of means? Lynn? Nope, but good guess. Multiply. Of means multiply.
Doesn't mean plus one?
Nope, just multiply. So if I tell you that I want to take 10%, turn around, Samuel, please, of something, it means we can actually multiply to get that solution. There are two basic ways that we have found to find a percentage, okay? And we're going to talk about them very briefly. We'll come back to them a little bit later. But you can change the percent into a decimal, and then you can multiply. And we all know how to multiply decimals, right?
No. Yes.
I'm going to cry. I taught you that already. Or we can turn that decimal into a fraction, and we can still multiply. We're going to talk about that in a second. Okay. Now, 100% means one whole. If I have 100% of something, it means I have the whole thing. So if 100% of my students are in school today, do I have anybody absent? No.
If you have to...
If 100% of my students are here today, nobody's absent. Okay? 100% represents all of them. Now, does that mean I have 100 kids in my class?
Yes.
No. No, if I tell you I have 100% of you here, in this case it's 35, I think, or 34. Oh, it changes. Whatever it is, let's say 35. If I tell you I have 100% of you here, all 35 students are in the room. Doesn't mean we have it out of 100. 100 represents the total of the percentage. So we have 100% of the students that are supposed to be here. Okay? Therefore, 100% of 85 is equal to 85. It represents the whole amount that we have. Okay? Now, that's just like changing 100% to its equivalent decimal 1 and multiplying by 85. If you have less than 100% of a number, the solution will be less than your original, right?
If you have an 85, does that mean a whole or like a half?
Well, it depends. So if I tell you I have 85%, that means some of my class would be missing that
Like
day.
15?
It depends on how many kids.
Example.
Well, it depends on how many kids are in the class. We're going to talk about that. So let's just say we want to find 75% of 36. Okay? So we know of means what? Multiply. And we talked about the fact that we can change that percentage into a decimal or to a fraction. Let's start with the fraction model. Okay? If 75% and if we have 75% and a percent is out of 100, guess how we turn it into to a fraction? Right? If every percentage is out of 100, then to turn it into a fraction, we literally put it over 100. It says I would have 75 out of every 100. Okay? Now, can I simplify that fraction?
No. Yes.
Yeah. By a factor of what? By 25. You go, Dustin. Think of these. These are money numbers, right? If we have quarters, that might help you look at it this way. If I divide, now you could have divided by 5 or 5, really. It equals 3 what? 3/4. So now look, in the example we've got here, Abdul. In the example we've got here, we are going to show some multiplication. This case, we took it and turned it into a decimal, and we'll talk about that in a second. But this one, we turned it into a fraction, and look at the fraction that we used. 3/4, because that's what we simplified this to be. Okay, does that make sense? we'll go on to the multiplication in a minute. Now, to turn it into a decimal is even easier. Because if we take 75 out of 100, read that as a proper fraction to me. How do you read that? 75 hundredths. Well, what does that look like as a decimal? 75 hundredths. Okay? Now, to turn a percent into a decimal, how many places did we end up moving the decimal?
One, not even one.
How many? 2. Look, we turned 75 into 0.1 or 0.75 or 75 hundredths. How many places did this decimal that was sitting way back here move? 1, 2. Okay? To turn any percent into a decimal, we move the decimal 2 places to the left every time. Uh-huh. It depends. If you've got, let's say you have 100 and something percent, right? Has anybody ever said I'm giving it 110%?
Yes.
That means I'm giving it more effort than I even exist in my body, right? But 110% of something, it does exist. If let's say that you end up, let's say that you end up paying for more than your fair share of a meal. You might be paying for 110% of your meal. And when we do that, your decimal moves 2 places. If we started at 110, let's just put this here. How many places do I move the decimal? Twice. So it always starts at the back. So it would be 1.10. And doesn't that make sense? Because this one whole represents 100%. Plus another 10%. Does that make sense? Okay. Yeah, really, I'm not trying to make this hard. Okay. And now we've already spent this part of this year multiplying by decimals and multiplying by fractions. So once we get them in those shapes, we should be able to translate that into a number. Samuel, do you have a question?
Yes. So basically simplifying.
No. We will simplify probably to get a fraction, but the process is not just basically simplifying. That's part of the process. Okay? Let's take a look. So if you look at the example here, I wanted to find out what 75% of 36 is. So all we did was change it to the decimal. How many places did we move it? 2. And then we multiplied because of means multiply. When we do the math, remember you got to count those decimal places at the end. And the answer is what? 27. Now let's take a look at the fractional version. Shh. We started with 75 hundredths and Samuel. And we simplified it to 3/4. When we multiply, we're going to simplify before we multiply. So these guys share a factor of 4, and that turns this into a 9 and this into a 1. When I multiply across, what do I get?
9.
Look, 27. 3 times 9, 27. 1 times 1 is?
1.
And 27 divided by 1 or over 1 equals 27. So it doesn't matter which way we do it, we're going to get it. Now, I'm going to take a second. I'm going to show you what this looks like in a proportion. Okay? So, in a proportion model, we're still looking at, I'm going to click this back so we can, we're still talking about 75% of what was it? 36. Thank you. Now, in a percent, what did I just tell you? Percents are always out of what number? 100. So this percent, 75, is out of 100. Now the question becomes, is this 36 my whole, or does it represent my part? Because remember, 75 is the part of a whole 100. Does that make sense? Yeah. This represents a part to whole relationship. Part to whole. So is 36 the part or the whole?
Whole. Part. Alright, raise your hand if you say part.
Listen, Abdul. Raise your hand if you think it's part. Raise your hand if you think it's whole. Okay. It's telling you I want 75% of 36. I don't know the 75% yet. 75% is my what? Part. I'm looking for 75%, so I must be looking for the part, which means they gave us the whole. 36 represents the whole.
But wait, if you have 36 to 75,
Hold on. We're going to talk about solving in a second. Let's talk about that again. I want to know what 75% of this number is, right?
Yeah.
I'm looking then for 75%. Well, 75% is the part. That's the piece I need to find. 36 is the whole. I want to know what 75% of 36 is. 36 is the whole. It's what we started with, and I want to know what part of that is, that 75%. Does that make sense?
Yeah.
Now, some people like to say, we use this abbreviation, is over of. Typically, your whole number, the number that represents the whole, pairs up with of. And if you see the word is, it usually pairs up with the part. So in this case, I'm trying to find a part of this whole. Does that make sense? Okay. Now, if I do that, we already simplified this fraction. What did we get it to be?
4.
Okay. So we know that this equals 3/4. How did I get from 4 to 36? Times 9. Whatever I do on the bottom.
You do on the top, which equals 27.
And isn't that what we found in the two examples we did? Okay.
So good.
Yep. Well, we don't have to simplify. What was I looking for?
The answer.
I was looking for this. So 27 is 75% of 36. And that's how you'd answer it.
But, wait.
Okay. Now, does that make sense? Is 75% less than 100?
Yes.
Is 27 less than 36?
Yes.
Is 75% more than half?
Yes.
Yeah, right? What would half of 36 be?
13.
18. Half of 36 would be 18. So we know 50% would be about 18, right? If we know that, we know that our number needs to be somewhere between 18 and 36, right? And so does 27 sort of fit right in between there? Absolutely. So it makes sense. One of the things that kids do a lot in this problem solving is that you get answers that don't make any sense, and you don't even realize they don't make sense. You got to know that we're looking at something that's a little smaller than 36, bigger than 18. Yes, sir.
What I would have done was basically like if I found out it was even, I'll make it to the half number and divide it by 2 again, and that would be a fraction of it equaling 2.5 over 4. And then I multiply that fraction by 3, and I get my answer.
It's very likely that I was losing you a little bit in the whole because I need to see it written out, but I'm sure that you're probably right. The deal is there's no one right way to solve these problems. What I want you to see is we can turn things into fractions. We can turn percents into fractions. We can turn a percent into a
Whole.
decimal, or we can use a proportion to solve these problems. So now we got another 3 methods. Let's take a look at a few problems and see if we can use that method, okay? All right, let me get my basket so I have my eraser. Okay. This is, all right, let's take a look at this. Before we get started, what I want you to do is I want you to look at these questions. I do not want you doing any calculations. What I want you to look at is what would be the only logical answer for each of these. If I want to do 90% of 40, what's the only answer there that would make sense based on my knowledge? 90% is really close to what? To 100. So if we're doing 90% of 40, our answer needs to be really close to 40. So what's the only thing that makes sense there? 36. Okay? So even before we did any math, we know, listen, what, hey?
I found an easy way to do it. Basically, take away the 2 zeros and then multiply 9 times 4.
Oh, that happened to work out there, yeah. Because that has to do with the fact that you could change it into a decimal. You're right. Listen to me again. For this section, all I want you to do is based on your knowledge and understanding of the relationship between these percentages, which of those answers will make sense? I'm going to give you guys 1 minute to answer those. Just circle the correct answer. Don't do any math calculations. Did you already get it, Dom?
I didn't make some math.
Why don't we do this? Can you make the notes that are well, 25%. Is that going to be closer to 0 or closer to 70? Right? So look at our choices here. So we know it can't be 0. Half of this is definitely small as this. Then so we're left with these. Which one is it? That's what you're in. write down this stuff then. Write it down. All right. Shh. About our, Lynn, if you're going to sit there, you need to be able to open the door without making a scene. Now listen, let's take a look at some of these. So when we look at 25%, let's start talking about our options here. 25%, is that closer to 0 or closer to 72? Closer to 0, right? It's below 50%. It's going the other direction. So we know instantly, first of all, which number can I cross off for sure? I can cross off 70. That's almost 100%.
54.
And we can, yeah, because what would be 50% or half of 72?
18. 54.
What would be half of 72?
50. 18.
You guys have paper, right?
2.5. 18.
Half of 72.
Oh, 38. 30. 36.
36. So we know instinctively that 50% represents half. So if we're looking at 25%, it's got to be less than 36. So 54 is out. Now, is it really, really tiny percentage?
No, it's not 2.5.
It's not. This is the only one that makes sense. All right. How about the third one? What do you think it is? Shh. Somebody I haven't talked to you yet today. Come on.
This is easy.
Something I have not talked to you yet today. Noah, which one? 800. 50% represents what? Half. Half of 100. 50% is half of 100.
Oh, so you're looking for the high number.
Well, we're looking for what makes sense based on what we know. Let's take a look at this one. Now, 110%. Is that more or less than we started with? More. So which numbers can we instantly cross off?
1.5.
And 25. They are not more than...
It's 115.
Now, shh, listen.
It's easy.
Look at this. We're going just a little bit more than 100%, right? So which of these numbers is just a little bit more than 55?
60.5.
That's the one that makes the most sense. Okay. Does that make sense? Hold on. Now, 5% of 80, is that a big number or a little number?
A little.
Little. So what can we get rid of automatically?
I mean, 804.
And, yeah, because these are all more than 100%, right? And 58. Leaves us with just 4. What I want, the reason for this exercise is, oftentimes you guys get answers, and you've done all your math calculations, and you made a math mistake. But, ladies, that's your last warning. I don't know, I just see talking or movement. Is that a problem going on? Okay. Oftentimes, guys, what happens is you guys get answers because you made a calculation mistake, something silly, and then when you answer it, you don't look at it to make sure it makes sense. Like, sit. I want you guys to actually make sense out of it. Know what 100% looks like. Know what 50% is, that kind of thing. All right, we are going to use all 3 methods to solve problem number 1. Okay? So let's start with which one?
Well, let's start with the butterfly method.
So let's start with proportions. All right? So we know that this is 50 out of what?
12. 50 out of 12.
No.
50 out of 100.
Thank you. Why is it 50 out of 100?
Because when you have percentage, it's always out of 100.
There you go. Thank you. Percent is out of what? 100. So we know that this fraction is going to, or this part of the proportion is this. This ratio is that. Now the question is the 12 the part or the whole? What is it?
Whole.
It's the whole, right? I want to find 50%, which means I want to find the part of that whole thing.
Simplify if you want to.
Now, yes, you can simplify. So what do we divide by? What can go into both? 50. 10 would work also, but let's go big or go home, right? So what do we get when we simplify here? 1/2. So how do I get from 2 to 12? Times 6, either way. And up here then? And doesn't it make sense that 6 is 50% of 12? Well, 50 is half of 100. 6 is half of 12. It makes sense. Now, on top of that, let's take a look at what this looks like if we made it into a decimal. Okay? I'm going to actually put a Post-it note here so you guys can see the separation. You may need to make some extra room on the bottom of your page. All right, if we were to turn this into a decimal, let's say that was the route we decided to take. What is 50% as a decimal? How many places do we move it? 2. So if we take 50%, we're going to move it 0.5. It's not a percentage anymore. Once we change it into a decimal, it's now a decimal. It's got a different meaning. So that 50, we're going to multiply, or 0.5, sorry, 0.50, we're going to multiply times 12. What's 2 times 0?
0.
What's 2 times 5? 10. What do we put down here as a placeholder?
0.
1 times 0?
0.
1 times 5?
5.
We're going to add. How many places do we have here? 2?
6.
So the answer is still 6. Okay? We should get 6, right? All of these methods should get us the same answer. Anybody have a question on how we did that?
No.
Okay. Now let's do the fraction method. Okay, so there's the decimal. Okay. Oops, I just dropped that. Let's do it using fractions this time. So how do I turn 50% into a fraction? It's what? Samuel.
You do like 2 and you move it to 22. I mean 20.
We're still on number 1.
Oh, you mean
Skylar.
You do 50 over 100.
50 over 100 is the fraction version, so we're using fractions to solve this time. And we're doing it of 12, so we are trying to find of 12. How do I turn 12 into a fraction? I put it over 1. Now, can we simplify before we multiply?
Yes.
Okay, this becomes 1/2 again, right?
Yes.
And can we still simplify before we multiply?
Yes.
Yeah, what goes into 2 and 12? 2. Divide by 2, I get.
1. 6.
Now, I'm going to multiply across. 1 times 6 is?
6.
Stop, please. 1 times 1 is? 1. And when I divide, 6 divided by 1 is? 6. So no matter which method we use, we can always find the same number.
Oh my.
Okay? Now, in light of the fact, what's wrong, Anastasia? You okay? In light of the fact that this whole unit has been focused on proportions, that's probably the method we're going to kind of go towards the most, but you can use any one of these 3. Okay? All right. So what I need from you guys is I want you, on your own, I want you to do the next 7, go up to 8. Each time, I want you to at least do one of each type. Does that make sense? You can use one method for almost all of them, but you need to at least do one with decimals, one with fractions, one as a proportion. And then you can use the method that you like the best for the rest. Does that make sense? So 1 decimal, 1 fraction, and 1 proportion. And then you can use whatever your favorite method is to do the rest of them. I don't care. Yeah. So 15 is the answer. Make sure you answer the questions too. Don't just do the math. I gotta know what the answer is. I'm gonna stop the video right here, guys, but I'll try to post one of these to the blog tonight.